Hello, viewers of my YouTube channel, Dr. C. Ganesh Teaching Modules. I welcome you to the fourth module in control systems under the series Success to Gate. I have already done 3 modules in Success to Gate. In this particular module also, questions from gate pertaining to time response analysis are taken. Questions from electrical engineering and chemical engineering gate question papers are taken and solved. Still some more questions are left in time response analysis. When I have glanced through the last 5 years question papers of various disciplines, so those questions, remaining questions, I will solve with explanations in my next module. So let me move on to this module. The first question is taken from GATE 2019 Chemical Engineering question paper. The question number 31. Choose the option that correctly matches the step response curves on the left with the appropriate transfer function on the right. The step input changes occurs at time t equal to 0. That means step responses, 4 step responses are given. Their corresponding transfer functions are given. It is also given that the change in the step input occurs at time t equal to 0. That means it is taken as causal system, that's all. Now 4 options are given. Instead of solving all the options, first let us take the first option and check whether we can come out with any conclusion. For example, for transfer function 1, we can find out first of all the step response. I am not going to solve completely by finding the partial fraction residues and all. Our aim is to just find out the nature of the response, step response. Here we can find that k into eta s plus 1 by s into tau s plus 1. So it has got a pole at origin and it has got a non-zero pole, and of course it has got a open loop 0 also. It has got 0 also, closed loop 0 also. So k greater than 0, eta greater than 0, tau greater than 0. So we were given 2 closed loop poles s equal to 0, s equal to minus 1 by tau, 1 0 closed loop 0 s equal to minus eta. And all these parameters k, eta and tau are greater than zeros. Now we can find the transfer function. From the transfer function, the step response in S domain is y by s, that is r of s multiplied by the transfer function, g of s into r of s, so 1 by s into this. Now the denominator will be s square. Therefore if you do the partial fraction, it will be a by s square plus b by s plus c by s plus 1 by tau. Of course this tau I have taken outside, so s plus 1 by tau. The tau also I combine with the numerator, finally resulting in this. If you take inverse Laplace transformation of this, a by s square is a into t, b by s is b, c by this is c into e power minus 1 by tau into t. We can find that at is always linearized, b is a constant one, it never varies with respect to time, and this is going to be an exponential decay. So linearized added to constant, then this is exponential decay. So finally it is going to be a rise only. Therefore we have to see among these 4 responses which is going to rise with respect to time. We can find that this response, it settles down, so it doesn't rise after some time. This rises with respect to time, it doesn't settle down to a finite value. Here again this settles down, here also settles down. Therefore this particular response, Q response, step response, is matching the behavior described by this particular equation, because a into t. So this is that a into t, that's all. This and this. So initially it rises, then that rise is decreased because of this decay term, that's all. This decay is added to the rise, but finally rise only dominating. Therefore option B is correct. Why I have concluded this particular transfer function, option Q is correct. So Q and 1. So Q and 1 among these four options, option B only we have Q1. In rest of the options Q1 is not there. Therefore we need not solve for remaining transfer functions. So we need not solve for remaining transfer functions at all. So it is enough if we conclude from this straight away, because Q equal to 1 is given only in this second option. So option B is correct. So let us move on to the next problem. So it is the problem taken from 2018 Electrical Engineering GATE question paper. Question number 9. Match the transfer functions of the second order systems with the nature of the systems given below. So the transfer functions are given, nature of the system, over damped, critically damped, under damped, all are given, and the options are given. Now just by seeing the transfer function, what we can conclude is it is of the standard second order form transfer function. That is omega n square by s square plus 2 zeta omega ns plus omega n square, where zeta is the damping ratio, omega n is the undamped natural frequency of oscillations. So if we compare each transfer function with this form, we can find out the nature quite easily. For example, for transfer function P, omega n square is 15, so 2 zeta omega n is 5. So this is 2 zeta omega n, this is omega n square. So if we solve by solving these two, we get zeta as less than 1. Zeta less than 1 means under damped. For Q, omega n square is 25, 2 zeta omega n is 10, that is what written here. Therefore zeta is this 1, which is critically damped. For R, omega n square is 35, 2 zeta omega n is 18. So if we solve these two, zeta is greater than 1. I have not got the exact numerical value. Just by seeing this, we can say 2 into root 35. Root 35 is almost close to 6. So 2 into 6 is almost 12. So slightly less than 12. So 18 by less than 12 is definitely greater than 1. Here again, root 15 is closer to 4 but less than 4. So 2 into 4 is less than 8. So 5 by closer to 8 is definitely less than 1. So that is why under damped, critically damped, over damped. So P under damped means P3, Q critically damped, that is second option, or first nature. Therefore P3 Q2 or 1. I think that falls into this third option. Option C only fits into this, because P3 under damped, Q2 critically damped, yes, R1 over damped. So option C is correct. So let us move on to the next problem. Consider a unity feedback system with the forward transfer function given by so and so. Steady state and the output of the system for a unit step input is dash. So we have to fill in the answer corrected to 2 decimal places. So this is a question asked in GATE 2018 Electrical Engineering question paper. Question number 25. We know very well that for a unit step input, position error constant Kp is given by this expression. Here it is unity feedback, therefore h of s is 1. So 1 by s plus 1 into s plus 2 is g of s, that is written. So as s tends to 0, it is 1 by 2, which is 0.5. So steady state error is 1 by 1 plus Kp, we know for a step input. You have already seen that. So 1 by 1 plus 0.5. So 1 by 1.5 is 2 by 3, which is 0.67. So 0.67 is the answer. So next question, it is again taken from Electrical Engineering GATE 2018 question paper. Question number 46. Unit step response is given of a unity feedback system. This is the open loop transfer function. The value of k is dash up to 2 decimal places. So we can find that this is the step response. So step response, we can find it is an under damped step response, but of course this is of a third order system, that is immaterial. Anyway, we know very well that it is a type 0 system, there is no polar origin. Therefore definitely there will be an error. So 0.8 it is actually settling down. 0.8 it is settling down, but input is 1. Therefore, the steady state error is 1 minus 0.8. Limit t tends to infinity, r of t minus e of t. So 1, because step input, unit step response only is given. So 1 minus 0.8. So 0.8 is a steady output. So 0.2. So for step input, we know the steady state error is given with a formula 1 by 1 plus kp equal to 0.2. And we know position error constant is given by this formula. Limit s into 0 g of s h of s. Last problem also we have seen. H of s is 1. So substituting s equal to 0. So k by 1 square into 2, which is k by 2. Therefore, the steady state error 1 by 1 plus kp equal to 0.2. So kp is actually k by 2. We have substituted from this, and this we have taken here. So 1 by 1 plus k by 2 is 0.2. So taking LCM, 2 by 2 plus k equal to 0.2. So 2 plus k equal to 10, therefore k equal to 8. So k equal to 8, so 8 is the correct answer. The last problem, consider the following transfer function. So this is taken from a chemical engineering question paper, where the natural period of oscillation is in minutes. Amplitude ratio at a frequency of 0.5 radian per minute is dash. So the answer should be given rounded off to second decimal place. So the amplitude ratio in frequency domain s is equal to j omega, if we substitute 3 by 1 plus j phi omega. Therefore square root of 1 plus phi omega all square, real part square plus imaginary part square. So 3 by root of 1 plus phi omega square for this one bracket. Square means root of 1 plus phi omega all square, because 1 plus j phi omega is root of 1 plus phi omega square. So 2 square roots should be multiplied. So if we multiply these two, we will get 3 divided by 1 plus 25 omega square, because 1 plus phi omega all square is 1 plus 25 omega. So square root into square means square root will go off. So in this we have to substitute the frequency as 0.5 radian per minute. So substituting omega as 0.5 radian per minute. So 1 plus 25 into 0.5 square. So on simplification we get 0.41. So in this module, as usual, we have solved 5 questions, like question module 2, module 3. So here again we have taken questions from time response analysis. Only the last question we have taken from the correlation of time and frequency domain specifications, that is the introduction to frequency response analysis. So what problem, what video should be referred for more detailed study, and what is the URL of the video, all that I have given as usual for each problem. So if you want to have a detailed study or revision of topics, kindly refer these videos under my channel. So I want you to post your queries, comments or feedback to this mail. You can also do the WhatsApp to this number 999-4347-426. So I thank you very much for your support in terms of views, subscriptions and sharing of my videos. I am sure that you will render more support to me in the forthcoming videos also, and I will definitely do better in the forthcoming videos with more questions. Thank you.